Hey guys, good morning. Today I'm gonna talk a little bit about microgrids and what they stand for and what's their importance in today's research. So before I start, I'd like to introduce a little bit about myself. So my name is Khurram Hashemi, and I've done my bachelor's and master's and PhD in electrical engineering, and I have majored in the control of microgrids and modern power systems. So currently I'm teaching at the University of Engineering and Technology, Lahore. This is in Pakistan and is one of the biggest and most prestigious institutes in Pakistan. It's also the oldest, so established somewhere around 1870s, right? And gradually developed into a big university. So it's an old institute with old traditions. I have just joined it in 2014, and then I left in 2016 to do my PhD, and then came back in 2021. So I spent this time in China, Shanghai. It was a pretty good time. So I'm going to talk about that some other time. But for today, before we start what a microgrid is, I'd like to talk a little about what is the power system and what it traditionally looks like. So traditionally we have a source end, and this is most likely diesel fuel or like a fossil fuel based something. So it might be a fuel that is coal or oil, and then we have some combustion chamber where this is burnt, right? Let's use some other color for the fire. And then we have a couple of exhaust gases that go into a turbine, and they run the gas turbine, which produces a motion that is like angular motion, right? And connected to this is a generator with a rotating rotor that is excited by a DC voltage source and current source, right? And then we have coils here that produce the AC current, ABC, right? So this looks like, I'm gonna approximate this by the symbol this. So we have a generator, AC generator, and then because this generation is around 3 kV, we step it up to around 33 kilovolts, right? So this is kilovolt. And then we step it up again to around 132 kilovolts. And then we have in many countries we call this the primary transmission, right? So this is a 3-phase connection, and then we step it up again to around 500 kV. And then we have the large transmission lines that carry these A, B, C wires, 500 kV. Mostly this is AC, but it might also be stepped up and rectified to DC, right? So we might have a DC transmission, but I'm going to leave that for later and continue from here. So at the delivery end, we just step this down to 132 kV, and then again to 33 kV using transformers, and then finally we have a situation like this when we step this down to 11 kV, and we have different feeders. So we call this transmission line feeder, and then we have distribution transformers that step this down further to 415 volts line to line in Pakistan, and 230 volts line to neutral. All right, so if you look at the distribution network, it's like this. So we have a transformer. The primary is usually in delta, the secondary is in star, and I'm going to draw some more of these. And then we have three-phase 4-wire connections, so A, B, C, neutral, A, B, C, neutral. So this is the kind of thing that we have here. And then each user might get a connection from line to neutral, or a three-phase connection, right? So traditionally what happens, I'm going to approximate all of this by a single line, and this means a three-phase connection, right? So what happens is that traditionally there are more than one consumers getting their power from the grid, right? So this kind of thing can only happen if the voltage at this end is higher than the voltage at this end. So this is the transmission end, and this is the receiving end for this distribution transmission line, or distribution feeder, you can say. So what happens is that when you have a situation where you have PVs and different diesel generators at the consumer end, as it is common these days, and you have battery energy storage systems that might store and then might send the energy back to the grid. So what we have is that when these are feeding energy into the grid, we might have a situation where the voltage profile might change and the receiving end voltage may be higher than the transmission end voltage. So this is going to disrupt the flow of power from here to here, or here to here. So what we need is that we have a situation where we can separate this via a switch, and then all these guys connected here with a couple of energy resources, power sources, storage resources, can manage their small micro power system independently. So we might have a situation that this might be completely independent from this, and we might have a couple of micro networks. So one name for these micro networks is a microgrid. So this is one microgrid, these are two, this is the second one, and going up till n. But bear in mind that this kind of thing requires energy storages, energy sources, and it also requires control resources such as computers and localized controllers that can regulate this system independently from this system, and this system independently from this system. So we might have local controllers, and then we might also have a distributed network operator here that's going to coordinate the energy flow, the power flow between these, and then the power flow between these and the greater power system. So this is the kind of thing that's happening these days. Also, microgrids started as a solution to distant communities that are located remotely, such as in mountains, and they have some houses that have PV modules installed, and some storages, and some powerhouses that are based on hydropower. So this idea started with such communities that needed independent control of their resources, and it was expensive to lay transmission lines, etc., etc. So the goal was to have and independent control here. And then over the years it has morphed into a new IDR where we can have independent control of different distribution networks together. So this is an overview that has of what's happening in the microgrid studies these days. And one interesting term that I'd like you to know is that before, when we used to consume energy, we had the term consumer. But when the consumer starts producing energy, producing power, we call him a producer who is also a consumer. So we are coming up with the term prosumer. So I'd like you to remember this, and I'm going to talk about this stuff and other interesting stuff in upcoming videos. So please subscribe to my channel and press the bell icon so that whenever I upload a video, you can see it just immediately. And you can contact me via email. So my email address is hurramhashemi@uit.edu.pk, and you can visit my channel, you can visit my LinkedIn. So just search Dr. Hurram Hashemi and you can find me on LinkedIn. Okay, have a good time, be happy, and keep learning about sustainable energy. Bye bye for now.